Hey everyone. So if you've ever written any JavaScript, you know the drill. You type some code, you hit run, and, well, it just works. But what is that magic happening behind the scenes? Today, we're going to pop the hood and see exactly what's going on between the moment you write a line of code and the moment your computer actually understands it. Let's get into it. I mean, really think about it. You write a variable, maybe a function. It kind of looks like English, right? But your computer? It only speaks in ones and zeros. So how in the world does that translation happen? That's the big question we're going to answer right now.
All right, first things first. Before we can understand how the code runs, we need to understand the world it lives in. This is the entire ecosystem that brings your instructions to life. And that ecosystem has a name, the JavaScript runtime. The easiest way to wrap your head around it is to just picture a big box. Inside this box is absolutely everything your code needs, not just to exist, but to actually run and interact with things like a web browser.
So if the runtime is the big box, what's the most important thing rattling around inside? Well, let's zoom in on the real heart of the operation, the JavaScript engine. The engine, this is the translator. It's the core program that does all the heavy lifting, taking your human-friendly JavaScript and turning it into instructions the computer's processor can actually understand and execute. Every browser has one, but you've probably heard of the most famous one, Google's V8 engine. It's the powerhouse behind both Chrome and Node.js. Now, this engine is really made of two main parts. First, you've got the call stack. Think of this like your workbench. It's where the action is, where your code gets executed one command at a time, right in order. Then you have the heap. The heap is like a giant messy warehouse. It's this big, unstructured pool of memory where all your objects, variables, and data get stored until the workbench needs them.
Okay, so we know the engine is our translator, but how does it do it? This gets us to a really fundamental question in programming. How do you turn text into action? Historically, there have been two main ways to solve this problem. The first method is called compilation. With this one, you take your entire program, you translate it into machine code all at once, and you get a brand new file. It's an all-or-nothing deal that happens completely upfront before you even run the program.
And then you've got the other way, interpretation. In this model, a program called an interpreter reads your code line by line by line, translating and running each command as it goes. It's a simultaneous process. And fun fact, JavaScript used to be a purely interpreted language.
So we have the all-at-once method and the line-by-line method. Which one do you think a modern engine like V8 uses to give us the incredible speed we expect from our apps today?
And the answer, which is just brilliant, is both. Modern JavaScript engines use this amazing hybrid approach called just-in-time, or JIT, compilation. It literally takes the best parts of both worlds to squeeze out every last drop of performance. So what does this just-in-time process actually look like? When your code hits the engine, it goes on this fascinating, multi-step journey from simple text to highly optimized machine code. It all unfolds in 4 key stages. First, the code gets parsed. Then, it's compiled and immediately executed. But, and this is the cool part, it doesn't stop there. The final, and maybe the cleverest step of all, is optimization. Let's break each of these down. Okay, step 1 is parsing. The engine grabs your code and breaks it down into this data structure called an abstract syntax tree, or an AST. This tree basically represents the grammatical structure of your code in a way the engine can work with. Now, don't worry, you don't need to know how to read an AST. Just know this is how the engine first makes sense of what you wrote. So, next up, compilation and execution. The engine takes that tree we just talked about and compiles it into a baseline, pretty unoptimized version of machine code. And because this is just in time, it starts running that code right away. Your program is now live. But the engine's work is far from over. And this is where the real magic of JIT compilation happens. While your code is already running, the engine is in the background watching. It's looking for patterns, finding functions that get called over and over again, what we call hot functions. It then takes those pieces, recompiles them into highly optimized machine code, and swaps them in on the fly. It is literally making your code faster while it's executing. How cool is that?
So, we've gone deep into how the engine works its magic. Now, let's zoom back out and put that amazing engine back inside our big box, the runtime, to see how all the pieces of this puzzle fit together. You see, the engine isn't working in a vacuum. It gets help from something called web APIs. These are features provided by the browser, things like timers or the ability to manipulate the web page, the DOM. Here's a key thing to remember. These are not part of the JavaScript language itself. When one of these API tasks finishes, its function gets put in a waiting line called the callback queue. And finally, you have the event loop. Think of it as the manager. Its only job is to constantly check if the call stack, our workbench, is empty. If it is, the event loop grabs the first task from the queue and sends it over to the stack to be executed.
Let's walk through a quick example. Imagine you use setTimeout to run a function in 2 seconds. The web API in the browser handles the 2-second countdown. Once it's done, the function you wanted to run is placed in the callback queue. The event loop sees that the main call stack is now empty and says, "All right, your turn," and it pushes your function onto the stack, and it finally runs. This whole system is exactly how a long download doesn't just freeze your entire web page.
Okay, I know that was a lot of technical stuff. The engine, JIP, the event loop, but why does any of this actually matter? How does knowing what's under the hood actually make you a better coder? Because it is absolutely not just theory. Understanding this whole process finally explains why a set timeout with a 0-second delay doesn't run immediately. It helps you track down those impossible-to-find bugs with asynchronous code. And when you understand how the engine optimizes things, you can actually start writing code that's easier for the engine to make fast, which leads to way more efficient applications. So I'll leave you with this final thought to chew on. Now that you've seen the machinery, now that you've seen all the gears turning inside the engine, what part of your own code, maybe it's a promise, an event listener, or just a for loop, are you going to look at with a completely new perspective? Thanks so much for joining me.